In this class, we are going to discuss about the convolution. As we have already discussed convolution in signals and system, just I am going to recall the concept. We know that convolution is a mathematical way of combining two signals to form a third signal. Consider an LTI system. Here, linear time invariant system, and the response of the system is denoted by h of t or h of n. Here h of t represent it is a continuous time system, h of n represent it is a discrete time system. And similarly, when the input is x of t, that is continuous time, the impulse response of the system is h of t, you will obtain the output y of t. When the input is discrete time x of n, the impulse response of the system is denoted by h of n and the output of the system is denoted by y of n. Okay, in order to obtain the output, what we need to do is we need to perform convolution of the input signal x of n or x of t with the impulse response of the system. So in order to perform convolution in for a continuous time signal as well as for discrete time signal, if you want to perform convolution for continuous time signals, we will go for convolutional integral, and if you want to perform convolution for a discrete time signal, we will choose a convolutional sum. So we have already familiar with these two formulas where y of t is equal to x of t, convolution h of t, where y of t equal to integral minus infinity to infinity x of tau h of t minus tau d tau. Next is convolutional sum. Same, instead of here you are having a discrete time sequence, the formula is y of n is equal to summation k equal to minus infinity to infinity x of k and h of n minus k. This convolution is a very powerful technique that can be used to calculate the zero state response of a system to an arbitrary input by using the impulse response of the system. As we have already discussed in signals and system about this convolutional integral and convolutional sum, now we are going to discuss about only the circular convolution. Because of in DFT, we are going to relate circular convolution with DFT. So in this linear convolutional sum, we can do it in two ways. One is linear convolution and another one is circular convolution. The operation involved in this circular convolution is folding, shifting, product and summation bar integration. Consider this convolutional integral formula. So when you see the integral formula, we need to keep one signal as such and we need to perform shifting in another signal. So first what we need to do is we need to perform the folding operation. So here you are having folding operation. Then if we need to perform h of t minus tau, we need to know the shifting operation. If we want, then after performing shifting operation, we need to perform product of these two signals. So here we are having the product operation. So these three operations are same for both convolutional integral and sum, and the only difference is summation and integration will differ. In continuous time signal, we will choose integration, and in convolutional sum, we will use summation. So see here, in this in order to perform circular convolution, you need to satisfy some conditions. The first, we can apply the circular convolution for a periodic sequence. That is the first thing. We need to apply for a periodic sequence. Then if x1 of n and x2 of n are the two input signal with a period n, then this convolutional formula, right, can be written as x3 of n is equal to summation n is equal to 0 to n minus 1, x1 of n, x2 of n minus m, which this n represent the periodicity. Next concept you need to consider is zero padding. That is, both the input sequence x1 of n and x2 of n should be of same length. If they are not equal in length, we need to append zeros at the end of the sequence to make the two sequence equal. Consider the input x1 of n is equal to 1, 2, 3, 4 and x2 of n is equal to 2, 3. Here the sequence of x2 of n is lesser than x1 of n. In order to perform circular convolution, we need to append zeros at last to make the two sequence equal. Here the length of x of n is 4. So here also we need to make x2 of n 4. So 2, 3, 0, 0. So we have append zeros at last, and this concept is known as zero padding. Now we will see one problem in order to perform circular convolution. Consider the two sequence x1 of n and x2 of n given. So we need to perform circular convolution. First we need to check the length of the sequence. Here the length of the sequence is 4. Here also the length of the sequence is 4. So there is no need to append zeros. Now consider the circular convolution formula. Now here n is equal to 4. I am going to rewrite this formula as sum x3 of m is equal to summation n is equal to 0 to 3 x1 of n, x2 of m minus n. This represents periodicity, and this m varies from 0, 1, 2, 3. Then we need to substitute the different values of m. First m is equal to 0, so here will become 0. So summation 0 to 3 x1 of n, x2 of minus n. Similarly, when m is equal to 1, x3 of n, summation n is equal to 0 to 3 x1 of n, x2 of 1 minus n. Similarly, if m is equal to 2, here we will get x3 of 2, summation n is equal to 0 to 3 x1 of n, x2 of 2 minus 1. Similarly, for 3 you will get x2 of 3 minus 1. So what are the operation you need to do? First you need to do the x2 of minus n operation, which is nothing but the folding operation. Then we need to do shifting operation. How will you do shifting operation? By shifting this x2 of minus n one time. Then x2 of 2 minus 1 we need to perform. Then x2 of 3 minus n. Then we need to perform multiplication for these two input sequence. Then finally you need to submit. So you need to perform folding operation, multiplication operation and summation operation. In this case, already folded sequence is taken here. So folding, shifting, multiplication and summation. Similarly, I am going to repeat for these two sequence. So we have already know that in linear convolution we will use graphical method for plotting the input sequence. Here we are going to use a circular convolution. So here we are going to represent this, you are going to represent using this circular form. First consider x1 of n is equal to 2, 1, 2, 1. Here the origin of the sequence is not mentioned. So we need to consider the first sequence is the value at the origin. So I am considering x1 of n. I am considering a circle. I am dividing this, I am plotting this sequence as first I am going to start from this side x1 of 0 clockwise direction, counterclockwise direction. So x1 of 0, x1 of 1, x1 of 2 and x1 of 3. Similarly for x2 of n. So here I am going to start x2 of 0, x2 of n, x2 of 2 and x2 of 3. Then write down the values of the sequence. Now I have written the values. x1 of n is 2, 1, 2, 1. Here 1, 2, 3, 4. The first operation we need to perform is reversal, that is folding operation. So in graphical method, how will you perform this shifting? So consider this is the origin. So if you perform folding, this value should be represented here and this value, this both will be interchanged, right? Similarly here we are going to consider this as the axis. I am going to interchange these two values. So here what you will get, x2 of 0 will be represented as such. Here you will get x2 of 2 is equal to 3. Only these two value is going to change. So here you will get x2 of 3 as 4. Here you will get x2 of 1 as 2. So this is what we need to perform the shifting operation. We need to perform the folding operation. So if we want to find x3 of 0, I have performed this x2 of minus n. Then what I need to do, I need to multiply x1 of n and x2 of minus n. Then I need to perform summation. Now what I am going to do is I am going to multiply this x1 of n value with this x1 of n and I am going to plot it here. So when I perform multiplication, what I will get, I will multiply these two sequence. So 1 into 4, 4, 2 into 1, 2, 1 into 2, 2, 2 into 3 6. So after multiplication, consider this, I have performed multiplication, then finally I need to do summation. So how I need to sum is, I need to sum all these values. So 2 plus 4 plus 6 plus 2. So what you will get? You will get the answer as 14. So x3 of 0 is 14 now. Similarly, I need to perform the remaining concept. So how can I perform is, here in order to perform x3 of 1, I need to perform x2 of 1 minus n. So I need to find out x2 of 1 minus n here. So if I shift this 1 times, it is enough. So I will get x2 of 1 minus n. So I need to shift in this manner. So x2 of 0 will come here, x2 of 3 will go here, and x2 of 2 will come in this place, and finally x2 of n will move into this place. So when I shift, 1 will come here, 4 will come here, 3 will come here, 2 will go here. Okay, so I got this. So finally I have performed this x2 of 1 minus n. Then what I need to do? I need to multiply. So this is the x1 of n sequence. I need to multiply these two sequence. When I multiply these two sequence, what I will get? I will get 4, 1, 8, 3. Then after multiplication, what I need to perform summation. So 4 plus 1 plus 8 plus 3, which is nothing but 16. So x3 of 1 is 16. Similarly, for x3 of 2, here I need to find x2 of 2 minus 1. I have shifted this sequence again 1 times. So x2 of will come in this position, x2 of 3 will come in this position, x2 of 2 will move here. So I have shifted. Then I need to perform multiplication with this input sequence. So when I multiplied, I am getting this sequence 2, 6, 4, 2. Then I need to perform summation. So 6 plus 2 plus 2 plus 4, 14. Similarly, I need to perform x2 of 3. So x3 of 3. So first I need to find x2 of 3 minus 1. x2 of 3 minus is obtained by shifting this sequence once. So here what I will get? x2 of 0 will come in this point. x2 of 3 will move this point. Then x2 of 3 here, move in this point, x2 of 2 will move here. So like that shifting will be done. Then after shifting, I have to perform multiplication of this with this input sequence. So I will get this answer. Finally I need to add. So I have got the value as 16. So finally, what are all the things we have done? I have done m is equal to 0, m is equal to 1, 2, 3. So the answer obtained is what? 14, 16, 14 and 16. So this is what the origin value. Like that we need to perform circular convolution. Here is another way to check whether your circular convolution obtained answer is correct by using this matrix method. So the same problem, x1 of n, x2 of n. So these are all the two that is the values at the origin. So here what we have actually done in convolution, we kept one signal as such, that is x1 of n we kept as such, and we have performed shifting in this x2 of n. Similarly, here I am going to write down this matrix. First I am going to write down this as a original sequence 1, 2, 3, 4. And the next line I am going to shift this by 1 like this. Okay. Then 4 again here. So for the next one I am going to shift like this. Okay. So we need to perform 4 times shifting in this way, and I need to perform multiplication. So first we have performed shifting. Then after shifting we have to perform multiplication, this row with this column. So I will get this answer 2 plus 4 plus 6 plus 2. Then the second row with this column. So I will get this answer. After multiplication, what we need to do? I need to perform summation. So I got the summation value as this. So this is the simplest form of performing circular convolution using matrix method. So now what you need to do is you try these two problems, okay, and perform circular convolution for these two problems and submit it as a tutorials.